Okay, so I'm going to start now. Hey guys, my name is Wilfrid. I am a senior math tutor. I'll be covering some high school mathematics today, primarily algebra and some functions. So I graduated from McMaster University with a major in biochemistry and a minor in mathematics. And today I'll be covering around 10 questions, so hopefully these questions will help you. And these questions were submitted through OneClass. So let's begin. Okay, so the first question has to deal with line equations. So the question reads, how do you write an equation in standard form with integer coefficients for the line with a slope 17 over 12 going through the point -5 over -3? So before we begin to tackle the question, there's a few things we want to define first. Namely, what is the standard form of a line equation and what is a line equation? So what is a line equation? So the line equation, as the name suggests, graphs a line and is of form y equals mx plus b. So y is the dependent variable. So what that means is that the value of y depends on what we call the independent variable. So whenever the independent variable changes, the dependent variable will change. So the slope, or m, is what it says is the slope of the line, so how steep or how not steep it is, I guess. And finally, we have the y-intercept, which tells the mathematician where the line intercepts the y-axis of the graph. So what is the standard form of a line equation? Well, the standard form of a line equation is we move all. I'm going to write it out in a different notation, or how the I guess the textbooks write it. You move all the variables to one side, and you keep the y-intercept or the b value on the left side. And this is a standard form of a line equation. It's just another way of writing the line equation. So how do we find the line equation or the standard form from this information? We're given two pieces of information here. We're given the slope of the line, which is m, and we're given a point where the line goes through. So these two information is enough to find our line equation. So let's begin. And one thing to note is that the solution that the junior tutor provided, he used the slope equation to convert to the standard form. So this solution is valid, but I'm not going to work through this solution itself. I'm going to work through an alternative solution and come to the same conclusion in the end, okay? So right now we have, we have y equals mx plus b. We're given m, which is 17 over 12. Okay, so how would we find b, right? Well, we're given a point that the line goes through, right? So we can substitute x equals -5 and y equals -3 into our line equation, and we can isolate for b, or our y-intercept, to find b. Okay, so -3 equals 17 over 12, -5 plus b. Okay. So moving b to the right side or left side, and moving everything else to the left side, we get this. Okay, 5, and we have minus or plus 3. I think this should be a plus. Yes, this should be a plus. Sorry, that should be a plus. I was thinking what was going wrong here. So this should just be 5. Okay, so in the end, we have b equals 17 times 5 is 85 over 12. And this should be a minus, sorry, because I moved everything across. So 12 times 3 is 36 over 12. Okay, so this equals 3. 3 times 12 is 36. 36 divided by 12 is 3. So that's another way of writing it. 85 minus 36, because these are the same fractions, we can subtract these. That is 49 over 12. So now we have b equals 49 over 12. Okay, so now we have our whole equation here. We have our line equation, which is therefore y equals 17 over 12 x plus 49 over 12. Okay, moving everything to the left side, all the variables to one side, we have y minus 17 over 12 x equals 49 over 12. And finally, we're just going to get rid of the denominator just to make things simpler for us and make it less confusing. So we're going to multiply both sides by 12. So 12y minus 17x equals 49. So this, this is our standard form of the line equation. And let's check if our solution is the same as the junior tutor's. So he reversed the 17x and 12y. It doesn't really matter, but our solutions are correct. And that is how you find the standard form of a line equation. In this example here, the junior tutor used the slope equation to figure out, to derive our standard form. And from that, he just rearranged things to find our standard form. While on my solution, I found our original line equation, and then I rearranged the line equation to make our standard form. So this is correct. Good solution. This is the correct solution. Good job. Okay, so the solution is correct. All right, so moving on to the second question today. So the second question reads, what are the values of x given by the equation 11x squared minus 4x plus 1 using the quadratic formula? So when they're asking for the values of x, they're asking for the solutions to this equation when y equals 0. They're looking for the values of x that makes this equation equal to 0. Most of the times, you can actually just use factoring and cross multiplication to find the zeros of the solution of the equation, and then you can find the solutions to the equation. But sometimes you have to use a quadratic formula because it's not factorable or it's not easily recognizable what the solution is. So let me explain to you, or let me write out what the quadratic formula looks like. So the quadratic formula is negative b plus or minus the square roots. It's my square root. The square root of b squared minus 4ac, and that is all divided by 2a. So this is our quadratic formula, where b, a, and c are the coefficients of our quadratic equation. Okay, so this is just a lot of computation at this point, but you want to plug it in, you want to plug your coefficients into here, and you want to solve, and you want to simplify and find your zeros. The reason why there's a plus or minus, because there probably are possibly two zeros, or there's two solutions to your equation, and because of that you have your negative solution and your positive solution. So let's work it through it now. Okay, so x equals negative b plus or minus square root of b squared minus 4ac divided by 2a. Our b is negative 4, so negative negative cancel out. So we have 4 plus or minus b squared is 16 minus 4 times a is 11, 44 times 1, which is 44 still. Our denominator includes 2a, so it's 22. Okay, so we're going to simplify this square root here. So we have 4 plus or minus 28, negative 28. So at this point, we kind of want to stop because there's a rule for square roots that you can't square root a negative number. That just doesn't make sense. So many mathematicians came up with a rule where they introduced a new number called I, imaginary number. And I is equivalent to negative 1. So now we can bypass having an invalid solution by using I. Okay? So I'm just going to break it up. So I want to say 7. So negative 28 is equivalent to 7 times 4 times negative 1 over 22. All right. And now we can take out the 4. So since 4 is able to be square rooted to 2, we can take it out. And we can also, the square root of -1 is I. So all we're left with, in fact, is this number here. 2 times the square root of 7 times I divided by 22. So now our solutions are going to be complex numbers. Okay, so therefore our solutions are, so now I'm going to write out the positive solution and the negative solution. Okay, so our positive solution is going to be 2 over 11 plus root 7 times I divided by 11. And our negative solution is going to be 2 over 11 minus root 7 times I over 11. So that's our positive solution and our negative solution. And these values, if they're the values of x, will solve our quadratic formula when y equals 0. Okay? So looking at our junior tutor solution is pretty much equivalent, and they came up with the same conclusion. They came up with complex numbers. And what complex numbers are in the end are they have a real value component, a real number component, and an imaginary component. So that's what all complex numbers are, but I don't think we need to explain any further. So the solution is correct. Correct. Good stuff. All right, cool. Let's move on to the next one. Okay, so question number 3. Expand x minus 2 cubed. Okay, so whenever you're expanding anything, that means that they want you to list out all the terms of this equation. So x minus 2 cubed is equivalent to saying x minus 2 times x minus 2 times x minus 2. Okay, so we're going to use FOIL, and if you guys don't know what FOIL stands for, it means first, outside, inside, and last. So it's a way of trying to explain how to expand these factors, okay? So let me kind of illustrate what FOIL means. Okay, so what it means by first, it means that it wants you to multiply this term plus this term. When it tells you to multiply it outside, it's this term times this term. When it tells you to multiply the inside, it's this term times that term. And when it tells you to multiply the last terms, it's this term multiplied by this term, and you add them all together, okay? So that's what FOIL means. First, outside, inside, last. Okay, so we're gonna do that right now, real quick. So first is gonna be x squared. Outside is gonna be negative 2x. Inside is gonna be negative 2x. And last is gonna be plus 4. And that is our first FOIL. Okay, so I'm gonna simplify that, which equals x squared minus 4x plus 4, right, times x minus 2. But we're not done expanding this. We still have this other factor that we need to expand, so we need to do it again. Okay, so but this time we have 3 terms, so FOIL doesn't really apply here, but the same principle still applies. You want to multiply this term times this term times this term. I'm going to use different colors not to confuse you. This term times this term, and this term times this term. And finally, we want to take our red, and you want to take this term times this term, and this term times this term. And you want to add them all together, and that's how you expand it, and that's how you find all the terms of your polynomial or your function. Okay, so x squared times x is x cubed. X squared times negative 2x, or negative 2 is negative 2x squared. Negative 4x times x is negative 4x squared. Negative 4x times 2 is 8x. 4 times x is 4x. And 4 times negative 2 is negative 8. Okay, simplify it all together, and this is your expansion. It's 6, sorry, plus 12, I believe, unless I'm doing something wrong. 12 and minus 8. So that's the expansion of this question. Let's see if we were correct, or the junior tutor is correct. And our solutions line up. So that is the expansion of x minus 2 cubed. So if it's x minus 2 to the 4, you have a lot more expansion to do, and you have a lot more terms to multiply together. So it actually just takes practice to get used to all of this. So make sure that you practice your expansions of cubes, squares, powers to the 4, powers to the 5. So this solution, this is correct. Nice job. Okay, cool. So question number 3 is solved. There we go. Let's move on to question number 4. All right. So how do you solve the inequality 9h plus 2 is less than negative 79? So for those of you who are unaware of what an inequality is, it is the general term that encapsulates, I believe, 5 different types of mathematical symbols. So let's list them out here. Okay. So inequalities. So the first inequality that you guys all might know is the equal sign. That means that the left side and the right side are equal to each other. Okay. So the next sign is the sign right here, which is less than, which is a statement that says the left side of the equation will always be less than negative 79, or the right side, right? The opposite also applies. There's an inequality that says that the left side will always be greater than the right side. And you can see here that it can be, you know which way it is because the arrow is pointing towards the lesser quantity. Okay. There is less than or equal to, which means that the left side is less than or equal to the quantity on the right side. And finally, we have the opposite. Again, we have greater than or equal to, which says that the left side is always going to be greater or equal to the right side. And then we have these other ones. This means that it's way less than the right side. This means the left side is way greater than the right side. And sometimes this is also inequality. This means that they're never equal to each other. So these are all the inequalities. And in this specific question is saying that this quantity on the left side is always going to be less than a negative 79 on the right side. So what does this mean for h, right? So when it means what solve the inequality, that means that we're trying to look for values of h that make the statement always to be true. So there are going to be some values of h that are for sure going not to make the statement true. For example, there's a value of h is 1. If h was 1 here, it would be 9 times 1, which is 9, plus 11. 11 is not less than negative 79, right? So when they're asking you to solve the inequality, they're basically asking you to isolate for h and find the values of h where this statement will always be true. So like in any other question, we're actually isolating for h and we're solving for h, okay? So let's do that now. So our inequality is 9h plus 2 less than negative 79. Okay, so we're going to move this 2 to the right side. So we're going to subtract both sides by negative 2, which means that 9h is left because this equals 0, and we have negative 81. To get rid of this 9, we are going to divide both sides by 9. So we end up with h has to be always less than 9. Okay, so that is our solution to solve the inequality. H always has to be less than 9. So there's one thing to note. Oh, sorry. There's one thing to note is that whenever you are dividing or multiplying by a negative number, you have to flip the sign. So in our particular example, if we were to multiply, let's say, h by negative 1, we would have to flip the sign to a greater than. And that's just because of how negative signs work, and it flips the whole inequality to make sure that it's still true. Okay, so whenever you multiply or divide, sorry, divide by a negative number, the inequality flips. Except if it's an equal sign. If it's equal sign, you don't need to flip. I mean, if you flip the equal sign, it'll still be equal sign. So yeah, you don't need to flip the equal sign, okay? So yeah, that's the solution to this problem. Let's see if the junior tutor has the correct solution. To solve the inequality, we isolate for h4 inside. H has to be less than 9. And yep, so the solution is correct. This solution is good. Nice job. Okay, cool. So moving along, we are going to move to question number 5. All right, so question number 5 says simplify root 72. So this is actually a really basic question, but I really want to emphasize the fact that this is a very important skill, being able to simplify radicals and simplify square roots. And it takes a lot of practice, but sooner or later you'll be able to just really easily do these, and it will really help save some time during higher level mathematics. So the key to solving or simplifying this square root is by listing out the factors of 72. So the goal of simplifying is you want to get to a point where you can no longer square root the value, or it won't give you a whole number or integer. And by that point, you simplified the square root, right? So let's list out the factors of 72. So we have, so let's see here, factors of root 72. Okay, so let's look at the factors of root 72 here. We have always 1 and 72. And if you guys aren't aware of what factor is, a factor is basically the numbers that you multiply together to get 72. For example, if you multiply 72 times 1, you get 72. What else is a factor of 72? We know that 2 belongs in 72, but what's its paired factor? It's 36. Oh, 3. 3 is 24. 4 is 18, I believe. Yep, 18. 6 is 12. And finally, 8 is 9. And at that point, you get back to, you get to 12 and you get to 18, and it's the same factor. I don't believe there's any other factors, right? So you want to choose a factor pair where the square root can no longer be squared, but the other number can be a perfect square, right? So we see that with 8 and 9, because 8 and 9, the square root of 9 is 3, right? But you can square root this further, right? You can square root 4 out of this, right? The other value, the other pair here is 36 and 2, right? The square of 6 is 36, right? So now we have found our pair of factors that will help us simplify this, right? So root 72 can be broken down to be 36 times 2, right? And in radical form, this can be written out as 36 times root 2. Since 36 can be rooted, we write 6, and root 2 can be rooted. It's actually a rational number, but it's not really an integer if we square root it, so we're just going to leave it at 2. And this 6 times root 2 is equivalent to root 72, and in that way we have simplified root 72. So the junior tutor used a different solution here. So basically what he did, or what they did, was they broke up 72 into non-square rootable numbers, I guess you can say, and then they gathered them up, and then they moved them out of the square root to leave 2 here. So they saw that there are 3 2s, so that equals 2 times 2 squared, and they saw 2 3s, that's 3 squared, right? And in the same way I broke them up like this, they broke it up where they said, oh, let me square root this 2, let me square root this 2 squared, and let me square root this 3 squared. Square root of 2 squared is 2, square root of 3 squared is 3, so you just left a 2 times 3 times root 2. And 2 times 3 is 6, 6 times root 2, and that's the same solution as mine. So this is the correct solution. Good job. Okay, cool. All right, moving along. Question number 6. All right, determine the factors of x cubed minus 12x squared minus 2x plus 24 by grouping. So usually you can determine the factors of polynomials by factoring them, right? That's how you usually solve quadratic equations. You usually just factor them, use cross multiplication, or you can even use a quadratic equation. But what about these third degree polynomials are higher, right? How would you even factor this? It is factorable. You can also use long division to check your factors. But there's a very unique technique called grouping that will really help us find our factors very easily. So the process of grouping is that you want to essentially group together terms that you can factor out like variables, if that makes sense. Okay, so in this equation here, right, we can group this x cubed and negative 12x squared, and we can also group negative 2x and 24, right? So let's write that out here. So x cubed minus 12x squared minus 2x plus 24. Okay, so we want to group this. We want to group this term, these two terms together. Sorry, my circle, that was really bad. And this term together. Okay, so we're going to group that together, right? And let's look at the first group, right? What is factorable out of this group? We can't really factor out any numbers, right? Because this one has a constant of 1. There's no factors of 1 here. But we can factor out x squared. So let's do that, right? X squared, x minus 12, right? So we factor x squared out. So x squared out of x cubed is x. X squared out of 12 is just 12. How about the second group here? What can we factor out, right? Instead of factoring out x, because there's no x here, we can factor out 2. So that's 2. And we're going to factor out negative 2 here, so it's going to be negative 12 because, or sorry, yeah. Okay. So now that we have factored out negative 12, factor out 2, right? We notice that this term and this term have the same factor. Now, it's not a number, it's not a variable. It's a combination of that. It's a variable subtracted by a number, but they have the same factor. So we can factor x minus 12 out of this and x minus 12 out of that. And what do we get? We get x minus 12 times x squared minus 2. So this is an alternative way of writing what we have here. And lo and behold, we have factored this long third degree polynomial by doing the grouping technique. And now that we know that one of the solutions is 12 and one of the solutions is positive and negative root 2. So that's how you solve, that's how you use the grouping technique, and that's how you are able to factor these longer and these higher degree polynomials. So let's see if our junior tutor is correct. So they used a lot of words here, and they use a very detailed description, which is very good actually. And yep, so they have the same solution. They kind of just left, they didn't group them together properly. So this is actually the right solution here, but this is also technically correct too. This is a good solution, very detailed. Okay, nice. All right, so we're halfway through everything. So let's move to question number 7. Okay, so question number 7 is how do you divide x cubed plus x squared minus x minus 1 divided by x minus 1? And they're asking us to use polynomial long division. Okay, so if anyone is unaware of polynomial long division, it's essentially like dividing numbers, except you're dividing a polynomial by a factor. And this is a very good way to check if your factor is, if your proposed factor is actually a factor of that polynomial. Because like just like numbers, if you have a remainder from your long division, then you know that your your proposed factor is not actually a factor of the polynomial. Okay? So I'm going to bring you guys through step by step of how to do long division here. So let's write out a division metric here. So x minus 1 divide x cubed plus x squared minus x minus 1 divided by x minus 1. Okay, so we know that we only have 2 terms here, x and minus 1, right? And we want to divide it into this polynomial. So the first thing that we see is how do we get So how do we get x cubed plus x squared, right? So we can say, oh, let's multiply this by x squared. So let's put x squared up here. Let's multiply this by x squared. So what do we get? If we multiply this by x squared, we get x cubed minus x squared, right? And the process of division, if in a long division, you subtract all this, right? So you subtract it. So now you're left with x cubed minus x cubed is 0. And you're left with 2x squared. Okay, let's bring down the next term down, negative x, right? So how do we get this to be subtracted from each other? We can say, let's times this by 2x. Okay, let's multiply this by 2x. And what do we get? We get 2x squared minus 2x. Okay, like usual, we subtract these together. We get 0. Minus minus is positive, so this is actually positive. 2x minus 1 is x. So we get x minus 1. Okay, so how do we get rid of this term? Well, essentially we just multiply by 1, right? So if we multiply by 1, it's x minus 1. Subtract, we get 0. There's no remainder. So when we divide it, we actually get the long division of this is now x minus 1 times x squared plus 2x plus 1. So now we know that x minus 1 is a factor through long division, and we found the other factor, which is x squared plus 2x plus 1. And that is further factorizable, but I won't do it here. Okay, cool. So they went through the process of long division. So the process of long division is a process which involves a division of a leading term of the dividend x cubed by a leading term of the divisor, right? So they show the process. And we get x squared plus 2x plus 1, which is a long division, and this is a good solution. Maybe let me clarify the solution here. The long division of x cubed plus x squared minus x minus 1 is x squared plus 2x plus 1. So that is the solution to the problem. Okay, so this is the correct solution. Good job. Okay, cool. All right, moving on. Question number 8. So the question reads, what is the value of f of g2 when f of x equals x plus 8 and g of x equals x squared minus 6x minus 7? So let me talk about composition functions real quick, because that's a concept that is needed to understand this question. Okay, so a composition function basically is a function of a function. So the inside function, as you would suspect, would take, let's say, it would take an x and map it to a y, right? So a composition function would then take that y and map it to a value, let's say z, okay? So if I were to write this out in correct notation, it would be, let's say there's an x, right? It would be mapped to g of x, right? So g of x, this x is mapped to g of x, and then the composition function, or the function of the function, will take g of x and map it to f of g of x, okay? So that's how a composition function works. So in this case, in our example, we're looking for g of 2, and whatever g of 2 is, f is going to take that and plug it into its own function and map out a final value, okay? So alternative way of writing f of g of x, we can also write f of x squared minus 6x minus 7. And if we write that out, so we're looking for g of 2. So 2 times 2 squared is 4, minus 12, minus 7. Okay, so that's g of 2. So now we're going to take f of this value here, right? So f of this value is 4 minus 12, negative 8, negative 15. So f of negative 15, right? F of negative 15, if we plug it in, would equal, let me just write this to the other side, will equal negative 15 plus 8, which equals negative 7. So in the end, f of g of 2 is equal to negative 7. Okay, so let's see if the junior tutor has a similar solution. To solve this problem, we need to evaluate first g of 2 to the function g of x. So they found g of 2, and they plugged in g of 2 to f of x. So f of negative 15 is negative 7. So therefore, f of g of 2 is negative 7. This is the correct solution. Good job. Okay, cool. Alright, the next question, question number 9. Alright, so before we talked about grouping, and now this is a classic factoring question. So the question reads, what are the solutions to the equation 0 equals x squared minus x minus 6? So we're finding the solutions of this quadratic equation, and we're going to use cross multiplication to solve this. So we need to find the values of x where this whole equation will equal 0, right? So we need to factor this, right? So factoring will help us because it simplifies the equation into 2 separate factors, and by that we can try to find what values of x will make this equation 0. So x squared minus x minus 6. How is this factorable, right? So we're going to talk about cross multiplication again, where it's basically taking the factors of this, multiplying it by the factors of this, and adding them together to get the middle term. Okay, so what's the factors of x, right? Which is this x and x, right? We can say negative x and negative x, but we're going to stick with these two x's. So what's the factors of 6? Negative 6, actually. It can either be negative 3 and times 2 or negative 2 times 3, right? In this case, I'm going to pick negative 3 times 2. We're going to cross multiply these things together, right? These two values together, and what we're going to get? We're going to get, so 2 times x is 2x, and x times 3 is negative 3x, and lo and behold, we get our middle term. So once you get this middle term, you know that these factors are correct, that these are the correct combination of factors to get the middle term. So now all you need to do is write it out in this format. So this is your first factor, x minus 3, and your second factor is x plus 2. So finally, our factors are x minus 3 and x plus 2 equals 0. Okay, so these are the factors, and this is an alternative way of writing out your quadratic formula or quadratic equation. But the benefit of writing it out in this factored form is that it is very easy for us to find the solutions to this equation, right? So we know that anything times 0 is 0, right? So all we need to know is what values of x minus 3 will be equal to 0, because if this is 0, then the whole thing is 0. And alternatively, what values of x plus 2, what values of x will make x plus 2 equal to 0, okay? So what values of x makes x minus 3 0? Well, if we isolate for x, we know x equals 3, right? What about x plus 2? What values of x will make this x plus 2 equal to 0? Well, if we move minus 2 to the other side, then it's x minus 2. So now we have found our two solutions to the equation, which is x equals 3 and x minus 2. And you can check that this is correct. If you plug x into here, or 3 into here, 3 minus 3 is 0. 3 plus 2 is 5, but 5 times 0 is 0. So 3 is a solution. Alternatively, x equals negative 2. If you plug negative 2 in here, it's negative 5. But negative 2 plus 2 is 0. 0 times negative 5 is 0. So therefore, the solutions to our equation are x equals 3 and x equals negative 2. Okay, so let's see if the junior tutor has the same solution. So yep, there's the same solution here, and because there's a multiple choice, he picked A and B. And he also factored it, but he didn't show the cross multiplication, but the factoring is also correct. So this is a good solution. Nice job. Okay, cool. Finally, let's cover the last question, question number 10. So this is not really a mathematical problem, but this is testing your knowledge of mathematical concepts. So the question reads, is pi a real number? So we need to define what real numbers are in the first place. Okay, so imagine this is your number line. Okay, actually I should have used this one. This is better. Imagine this is your number line. Okay, your number line is here. Positive infinity is this way. Negative infinity is this way. Let's say 0 is here. So a real number is described as anything that is on this number line. Okay. So a real number, this is the notation for a real number. Okay. So real numbers, they consist of your natural numbers, your integers, your rational numbers, which is just r, your irrational numbers. Okay, sorry. I think it's Z. Your irrational numbers. Right, so actually, I actually don't know the notation for that. But they consist of your natural numbers. So your natural numbers are your numbers that you can count, right? 0, 1, 2. So let me use a different marker for this. 0, 1, 2, 3, 4, 5, and so on. So 1, 2, 3, 4, 5. So your integers, they're including the natural numbers, but they also include the negative numbers. So -1, -2. Okay, also this this number line is not to scale. Okay. So your rational numbers, as they suggest, they're numbers that can be alternatively written as simple fractions. So for example, a natural number is a rational number, but a rational number is not a natural number. So numbers such as, I guess, like 3/2 or 1/2. Okay, so those are your irrational numbers, right? 1/4 is over here too, right? So those are your rational numbers. And finally, real numbers also can consist of irrational numbers, which cannot be composed of simple fractions, right? And the most defining characteristics of irrational numbers is that they never end, right? So √2 is a very good example of a rational number. The decimal keeps running on. Another really, really good example of an irrational number is pi. So pi is characterized as the ratio of the circumference of a circle to its diameter. It can also be written as 3.145 blah 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 blah, right? So this number, believe it or not, actually exists on the number line. You can see it here, right? You can see it like it's like somewhere around here. Oh, sorry, like it's somewhere around like here, right? Even though it runs on, right? It exists on the number line. So the only numbers that do not exist on the number line are what we call imaginary numbers, which are I, 2i, 3i, 4i, right? So those are the only numbers that do not exist on the real number line, right? So going back to our question, is pi a real number? Well, since it exists on the number line 3.145, even though it's continuously running, it does exist on the number line, so yes. Yes, pi is a real number. If it had an imaginary number component, it is no longer a real number. And I'll have one more illustration to show you guys how to think about it, okay? So let's say that this huge circle is all the real numbers, okay? They're all the real numbers, all right? So there's a small subset that are the natural numbers, right? So there's a small subset that, is that blue? It's not. There's a small subset that says that this is the natural numbers, okay? So the natural numbers, all natural numbers are real numbers, but not all real numbers are natural numbers. Okay? So then there is a slightly bigger circle encapsulating the natural number circle that explains, that explains that this is the integers, okay? So all the negative and all the positive numbers, these are the integers, okay? So all natural numbers are integers, but not all integers are natural numbers. So if you can see by this illustration, right? And then I'm also kind of running out, but we have a bigger circle around these two circles, or this oval, I guess, that explains that the rational numbers, right? The rational numbers, right? So all real numbers, all rational numbers are real numbers, but not all real numbers are rational numbers. All integers are rational numbers, and all natural numbers are rational numbers, but all rational numbers are not integers or natural numbers. Finally, we have this last circle which explains our irrational numbers. All right. So these are all the different types of numbers that consist or that compose the real number realm, I guess you can say. And then your imaginary number realm is over here, and they intersect through complex numbers, but that's an entirely different story unto itself. Okay, so that is the answer to the last question. Is pi a real number? Pi is a real number through our illustration of the number line and explaining what pi essentially is. So that concludes our tutoring session today. I covered a bunch of questions at the high school level pertaining to quadratics, the line equations, how to factor, how to long divide. If you have any other questions or have any questions from your homeworks or tests, please submit them through OneClass. I hope that you enjoyed today's tutoring session. I hope to see you guys again soon. Thank you so much for attending my lecture. And, oh yeah, I forgot to answer this. Yeah, yes. This is a good explanation of pi and the real number set. Okay. So yeah, thank you so much for listening. I hope to see you guys again soon, and I wish you guys a good night.